Let's prove some trolls incorrect. Let's go. I made a video explaining to some people that this is not 120 plus 120. That's not how you get your 240. What's actually happening is each leg cycles from positive 170 to negative 170 at exact opposite times, making a peak difference between the two of 340 volts. That's not the useful difference that will represent the work it can do. We'll talk about that in a second, but that is the peak difference. And if I hook one leg up to an oscilloscope, we can see it peaks at 170 and then is a negative 170 for an RMS. We're going to talk about RMS in a second, of 123. Because it's only that peak for an instant, we don't really care about that in our daily life. We want to know the variable voltage of that sine wave. How much work can it do? How many watts can it produce? So we apply a math formula called RMS, which takes the wave and turns it into the DC equivalent value. The reason we can't just take the average value of the wave is half the time it's negative and half the time it's positive. So if you do the average of half positive, half negative, you end up with 0. We know it will not do 0 volts worth of work. But is it possible, other than on the fancy oscilloscope there, is it possible, it's a cheap one, that's why I said fancy, but is it possible to capture the peak? Is it possible for me to show you 340 volts on a meter? Yes. Let me show you. So we have to get rid of the negatives. We have to bring everything positive, which turns it into a DC circuit. And you can do that with some diodes. And then we get to get rid of the valleys. And you get rid of the valleys with a capacitor. So we have 246 volts incoming AC RMS coming off that breaker. It goes through my diodes and my capacitor and comes out 341 volts DC. Thank you very much.